When my E30 cluster died, I thought 3D printing a replacement would be simple, but my first attempt was a disaster. The material was weak, and the screen mount looked terrible. So in this video, I'm going to show you how I fixed all the issues and redesigned a perfect 3D printed digital cluster dashboard. Now the first thing you'll need is a printable 3D file. You can make one yourself using a 3D scanner, but not everyone might have access to one. So I'm going to show you another way to get your printable file, or what's better known as an STL. And after a bit of Google searching, I found this pre-made design and it looks like it's gonna fit perfect. So for $30, that's not a bad deal. But now all we need is a 3D printer. So I did another search and bought the cheapest and biggest printer I could find. And that was mistake number one, because I quickly learned that certain filaments which are pretty easy to print with, like PLA, which is a bioplastic made from sugar, will melt in the cabin of your car on a hot summer's day. Even stepping up to PETG filament, which is petrol-based, can start to sag if directly exposed to the sun for longer periods of time in the cabin as well. So I found some material that can handle up to 200 degrees Fahrenheit, is UV resistant, and that's ASA. But my printer kept having warping issues, and I learned that's because ASA needs to stay warm during the entire print. And that's where the Bambu Lab H2S comes in. This thing is massive, and it can print around 13 inches wide to 13 inches deep and up to 13 inches tall. It also comes with a heated chamber and additional fans to keep the heat flowing inside the entire printer. Now that we have the right setup, it's time to tackle the second issue that I ran into. And that's the fact that our pre-made 3D cluster design didn't have any openings. I tried cutting the opening at first, but it just looked plain terrible. So the solution? Measure the screen and design the opening ourselves. So I jumped into one of the easiest and intuitive CAD software programs, Shaper 3D. With the measurements taken, I was able to create a template prototype to test fit the screen before 3D printing the entire dashboard again. And if you want to learn more about how to design your first car part, we have an entire workshop that I'll share in the video description below. Now, once the prototype was finished, I exported it as an STL and dropped it into the 3D printing slicing software, Bambu Studio. From here, I selected the printer and ASA filament, but before we hit print, there's one more thing you need to do. And that's prepping the ASA filament. Now we're going to be using the Bambu Lab AMS2, which does allow us to print parts in multicolor, but more importantly, this unit also has a built-in heater, and that's going to allow us to remove any moisture inside the filament. And that's important because if you print these filaments without first removing the moisture, you can have stringing, clogging, and other types of issues during the print. Now, if you're not using a Bambu Lab printer and you're using something else like a Centauri Carbon, you can use a filament dryer, something like this. This is a standalone filament dryer. You load your filament into the dryer, and it has this tube to feed your filament into another printer. That's going to allow you to run the dryer with a different printer and keep it drying even while the print is still going. And now that the filament is dry, we can go back into Bambu Studio and see how long the print is going to take. It'll take around 55 minutes of print time with 17 minutes of preparation, which includes auto bed leveling and flow dynamics calibration, which I recommend you run in order to get the best ASA print possible. All right, the prototype looks pretty good. And also just to note, if you print things on the bed, you'll also get this nice texture. So let's flip it around. Here's our mounts. And that's exactly what we want. We want the screen to sit flush to our mount points. And that actually looks pretty good. So now all we have to do is figure out how to get these measurements mashed into the original design that we downloaded earlier. So with the pre-made design, it's pretty tricky to modify it because it's one solid object. So instead of trying to merge the prototype with the opening and standoffs to the original file we downloaded, I'm going to redraw the STL file in Shaper 3D by copying it with the line tool, and once I have my shape, I can extrude the parts to match the original design. And since I'm recreating the design, that means I can make tons of improvements. So I'm going to flip the part around, which is how I want it to 3D print, and I'm going to readjust these overhangs with a 45-degree angle to prevent extra material to be printed up to hold those parts in place. Once the copy is done, I can import the STL file into Bamboo Studio, select the correct color of ASA filament, flip the part upside down, and angle it to fit on the print bed. But as you can see, there's nothing holding the overhangs for the screen, and that's where we add supports. And you'll also want to remove the small overhangs option. That way the supports are added for the screen as well. And now we're ready to 3D print this part. All right, so here's the moment of truth. Okay. Something is not right. The standoffs, for some reason, are not in the right spot. It almost looks like they're 2 millimeters off. Huh. So I think that's why they say measure twice and cut once, or print once. But this isn't a problem in Shaper 3D because we can open up the history tool and we can go back to the previous sketch where we have the dimensions for the opening, and we can reselect the measurement for the standoff and change it on the fly. And as we readjust that measurement, everything else changes with the history function. You can even go back and change other measurements as well, and that will modify all of the things done previously before. And we teach all of this in our workshop, which will also leave a link in the description below. So there's a few other issues that I think we could fix. One is, if you take a look, there's this clear line that runs all the way down the print. Let's see. You could see it like right there. So I think as the printer was getting higher on the print, that my heat settings weren't high enough. So I'm actually going to bump up the heated chamber in order to keep this printer a bit warm. It is a bit cooler here in the garage moving into the winter months, so make sure you bump up your heater, especially if you live in a colder area. Now, the second thing I also noticed is in some cases it looks like the print is different colors, so almost like a glossy and almost a matte finish in certain parts. Now that could be due to the print speed changing while it's going up into the larger sections. And there's also another setting in Bamboo Studio or whatever slicer that you use where we can make sure that the speed stays consistent through the entire print, and that's going to help with having the two different colors match. So we can make sure that our speed is the same as well before we run through the next print. Now the print will take 9 hours instead of 7 by reducing the volumetric speed, but there's one other setting that you can enable to help your print, and that's enabling a brim. The brim will add an extra layer around the outer side of the part on the first layer, and we're going to use 10. And here when we zoom in, you can see that an additional layer is being added, and this will help prevent the part from warping as well. Now you can change the brim width to be a bit thicker if your part is smaller at the base. So if we bump this up to 20, you can see that it now has added a thicker brim to the part. And with that new brim, with the heated chamber up and volumetric speed decreased, we're ready for the print. Now there are two things that I would change. One is the wall thickness here. I went with something a little bit thinner. I should have went with at least 4 millimeters in thickness. And also these angles can be slightly readjusted a bit. There was some filament that just didn't make it as it was printing up that angle. So readjusting that, and I think this would be the perfect print. And if you're interested in how to 3D scan your parts in detail and then print them, watch this next video right here.